first time I saw a lambda and I said to myself, my goodness, I think Anders fell off his chair and hit his head. This is ridiculous code tongue-twisty weirdness. And what has that guy been drinking? Why does it need to be so complicated? And I stopped myself. And I realized it's a natural reaction people have. They see complex things or stuff they're unfamiliar with, especially notation they're not familiar with, and they, people feel hesitant. Why do I need to adopt change right now? Well, if you feel this way, or maybe you're a .NET 1.1 or 2.0 developer and you're coming into 3.0 or 3.5, right now, and you're seeing these things called lambdas and people slinging code around using X's and arrows and equal signs, and you're wondering, what in the world is this? It's going to take me forever. This looks so completely opaque to me. Well, the screencast is for you. And the goal of the screencast is just to give you a level of familiarity so that when you do go read some blog posts on your own, you have a good starting point. So let's jump right into it. What I want to do is start with a typical list and show you where you might have seen these weird things before. If you've been keeping up with any of the link blog posts from Scott Goo or others, you've probably seen an example where a list is created of some kind and you have seen a method called where. And what this does is return a subset of the list, according to some criteria. In this case, we have a source. As you can see, the source is this list itself. And then this weird notation, func. What's a func? And then a predicate? I don't understand. This is really crunchy syntax. And I don't blame people for feeling a little bit put off by it. So the way that where works, basically, is you specify criteria using a thing called a lambda. So in this case, we might just say, x equals another string like me, for instance. Now, of course, if you're using an object, you can set values of that object, like if it's, some complex object, you can set a property equal to some value and so on. But basically, what we've done here is specify criteria. All right, well, let's start here by explaining what we're looking at. What is this wacky notation? Well, what it's saying is that this right here goes into this expression, or this function, if you want to call it. This is a left side and a right side. Every lambda has a left and a right. In this case, if you're wondering, what do you mean left and right? I don't understand. Well, let's open up IntelliSense one more time. The lambda is defined by a thing called a func. This is an on-the-fly delegate. You don't know what a delegate is? A delegate is just a method on the fly. We are defining a method on the fly. That is exactly what we're doing. This takes in a value. So right here, we take in a string and it returns a value, which is a Boolean. All right, simple enough. We're defining a method on the fly that takes a string and returns a Boolean. So here's our method on the fly, right here. This is a string. We're saying this string, the starter string that we have, goes into, or the criteria is going to be, the criteria is going into this expression. This is our Boolean. Okay, so that is how lambdas work in a nutshell. To understand these a little bit more, let's actually write one. So what I'm going to do here is simply write static func, and this is an on-the-fly delegate. Now if you can see the func keyword here, delegate, returns a delegate. A delegate, again, is basically, you can think of it as a method as a variable. So I'm going to define a method here, and I'm going to take in a decimal. And then I'm going to return a decimal. And then I'm going to evaluate this function right now. We'll call it, let's call it square it. So I give it a name. And then I'm going to say this delegate equals, and we say it equals on the fly here, x goes into, my started decimal goes into x times x. Okay, let's dissect this a little bit. We have a function called square it. This is our starter value here, decimal, and we're going to send that into this function, x times x. This is automatically going to return it. Whenever you invoke a func, the last thing operated, or this whole thing on the right side here, is our result. All right, so how do I use this? Let's take this out of here. What I'm going to do is I am just going to say var result equals square it. And if you're wondering why it's static, it's because I'm using a console application here. And this is static. Everything inside of the console app is static, so I had to make this static. You don't have to have static to have a function like this. Okay, so now I'm going to simply output this to the console, and we'll just output the result. And then I'm going to do console.readline. Sorry about my fat fingers. to keep our console from disappearing. So when I run this, our lambda gets evaluated and returns a 4. Great. Okay, so let's go over this one more time. Sometimes repetition is really the only way you can learn this kind of stuff. So here I'm defining a delegate on the fly. That's what func is, a delegate on the fly. And I'm telling it it's a simple function. It's named square it. And I'm going to start with a decimal. And then I'm going to shove that decimal into this operation. Left side, right side. Okay. Let's keep moving here. Let's do something a little bit different. I'm going to show you why this is useful. I mean, declaring something like this, it's good for shorthand notation. I mean, this saves me all of 2 or 3 lines of code, which is good, which is great. But if you want to do something a little bit more flexible, check this out. You can do something like, let's say static decimal. We'll call this calculator. This is a method I'm going to create, and it's going to take in a number. So we'll call this the number. And then it's also going to take in a delegate. And the delegate is something the user is going to create on the fly. So in this case, we're going to do a func. Decimal, decimal. Same thing as we did before. And then we'll just call this, we'll call this function. Okay. All right. So how do we use this now? Well, the user, the consumer, is going to specify this for us. Now, we explicitly defined it up here. We gave it a name and explicitly defined our delegate up here on the right side. We didn't define anything. We just said it's going to be a variable. The user is going to define it. Great. Well, now what we want to do is we just simply want to invoke it. So we're going to return function.invoke. It's going to ask us, we need one argument because you defined it as taking in a decimal. It will return a decimal, but we also need to take in a decimal. All right, so we'll just take in the number. That's it. All right, so how do I actually use this? Well, let's reset this, and we can say calculator. We're going to start with the number. Let's start with the number 11. It's a nice round number. I'm going to give it an M because that tags it as a decimal. And then I get to define my functionality on the fly. So this is where I get to use my lambda. I'm going to simply say x equals x, and then we'll say times 32 divided by 12 m. And let's see, let's just call it divided by 12, and then plus 1,000 minus 20. That's it. So now I've been able to find this little calculation on the fly. And so I can run this, and wow, that's a crazy number. Well, so you can see the power. This is the idea behind using functions and delegates. I was able to create this functionality right here. All right, so let's do a little bit more. Hopefully you're starting to see the power of lambdas. Well, as you notice, I'm doing a lot of console write line here. I can do that a little bit differently by using another groovy feature of C# 3.5 called the action. So what I can do here is I can simply create action. Again, this is a delegate. And what this does is exactly what it says. Encapsulates a method that takes a single parameter and doesn't return a value. All right, so what the heck does that mean? Well, it means that I'm writing a function, a void function on the fly. So what would be perfect for that? Well, how about console.writeLine? Okay, so I can do something like this. I can say object, and then I'll just say write it. Okay, and then I say this is going to equal, and then here come my lambdas. X goes into, and then I'm going to say console.writeLine x. Okay, well, the main difference between this and function, keep in mind, is that this is creating the ability for me to just quickly output values onto the console. And it's not going to return a single thing to me. So instead of doing console.writeLine now, I can just say write it. There we go. And if I run this, it does the same thing. Great. Okay, well, once again, I explicitly declared what my delegate is up here. And as you're starting to see this and you're starting to use it, hopefully you're starting to see this is delegate sugary syntax. Now, sugary syntax is a new word to you. It just means shorthand. This is all shorthanded stuff. That's what lambdas are. They're just basically ways of you to declare stuff without having to go through the rigmarole of doing for eaches and all this other stuff that, well, takes a lot more code. This just terses stuff right up. Okay, well, so how would this going to help us? Well, let's define this a little bit more so we can work with action just a little bit better. Let's create a class in here, and what I'm going to do is I am going to copy and paste one that I've already declared, and oops, I'm missing a. There we go. And I'm going to call this class Monkey Boy, and it's got a single method called Scream. All right, so let's use this as an argument here for something a little bit different. And what I can do is, as you probably can tell here, is I can write static void and yell, and then I can take in, let's just take in an item here. We'll take in a monkey boy, and then we'll say, well, tell me something to do with this item. And so in this case, we just say action, monkey boy, action. Great. Okay, well, so what are we going to do? Well, we'll just say action.invoke. And then we'll tell it invoke on monkey boy. Okay, if you've seen this word invoke before and you're saying, wait a minute, I saw that IntelliSense as you glance by. Well, let's address that right now. If I come over here and say action dot, yes, indeedy, method info, get types, and dynamic invocations. Yes, this is reflection. This is reflection made easy using lambdas. And before you freak out and say, oh my gosh, reflection's horrible, don't ever use it. Yeah, not really. Think of it this way. 3.5 is a lot faster when it comes to reflection, and using lambdas in a way like this, well, that it makes things a lot easier when it comes down to using reflection when you have to. And in this case, you might want to just do something here on monkey boy, and you don't know what action you want to do. So in this case, let's show you what I mean by that. And so I am going to simply use the word, or not the word, the method yell. And let's just say new monkey boy. And in here, I need to give it an action. In this case, I give it another lambda. And I just tell it scream. That's it. Now here, I'm passing this method. This method is a method on monkey boy, which is kind of fun. And I'm telling it to do this on the fly. So let's change that and run it. And there it is. So it invokes that method for us. We just define it right here. Now, if I wanted to play around with this thing a little bit more, I could say something like var method equals action.method.name, and then I would know what the name of that method is. In fact, if you're wondering how, when I originally built the HTML helpers a way long time ago, we were able to capture routing information, it's because we used action controller. Okay, so there we are. We've got this to work. Well, what if I wanted to do something else? Well, let's see how this might work. We might do something like scream, and we might do something like, let's do another one. Let's just say cheer. And we could do something like go Windows 7. Woohoo! 7 spelled properly. Okay, well now we can change this on the fly in our calling code. This doesn't really do much of anything. Doesn't ever change. The calling code, however, can simply say cheer, which is super groovy. Now you can see how this is loosening things up a little bit by using lambdas, and if I run this, you can see go Windows 7. There's a lot more I can go into right now, talking about lambdas and expressions and all the features in .NET, but the focus of this, again, is just to get you past the hurdle of diving into lambdas. And I will devote another screencast to expressions and expression trees and how those things go together in defining lambdas. I built Subsonic using Subsonic 3.0 using expression trees and lambdas, and I got to tell you, it's a lot of fun once I started getting into it. There's a lot more to this stuff. I hope you've enjoyed it, and do leave some comments if you have any questions. Thank you.